We will learn about the first order circuits where you have a resistors and inductor, or a resistors and capacitor. So we are learning about charging and discharging. Last time we discussed about the capacitors and inductors, but under the DC condition. So when they are fully charged or fully discharged, how they work, how they act in a circuit. That's what we did last topic. But this one we are going to learn what is happening when we are charging and discharging. Okay, so it's really important. As I have mentioned, you have one question in your final exam. So first order circuit is characterized by a first order differential equation. That's why we call them first order circuits. And circuits can only contain one energy storage element. So it can be either a capacitor or an inductor, and with resistors. So when we have circuit with capacitors and resistors, we call that RC circuits, and when you have inductors and resistors together, we call that RL circuit. So we have RC and RL, so they both together we are not discussing here. We only consider one capacitor or one inductor in a circuit. So RC circuit with capacitor and resistor, and resistors, you can have many resistors. RL circuits with inductors and resistors. So you can see these two as an example. So here in the second circuit you have one inductor with many resistors, and in the first one you have one capacitor with resistors. So we are talking about charging and discharging of these ones. So we are discussing about two situations, but when we get the last equations, we can use that even for any situation. Okay, so source free RC circuit, that means you don't have a source. Source can be a voltage source or a current source. So when we don't have a source, we call that a source free circuit, and we call that is the natural response of a RC circuit. A source free circuit is one where all independent sources have been disconnected from the circuit after some switch action. So the capacitor or the inductor is fully charged, and we take the source out. So we are going to learn how this capacitor or inductor is discharging. So after some time, the capacitor will be fully discharged and the inductor will be fully discharged. The voltage and the current in the circuit typically will have some transient response due to the initial condition, initial capacitor voltage and the initial inductor current. The natural response of the circuit refers to the behavior in terms of voltage and current of the circuit itself, with no external sources of the excitation. So this is the first part, and we will learn with the sources as well when we move on. We will begin with analyzing source-free circuits, as they are the simplest type, and later we will analyze circuits that also contain sources after initial switch action. So we will learn both the type. As I have mentioned, if you learn this with source condition, it will help, we can use that for even for the natural responses as well. Okay, so this one we call the source free circuit, because you don't see any sources. Do you see any sources in this circuit? It is very simple. And the source free, this is a RC circuit. Why we call it RC circuit? Because it has resistors and a capacitor. When its DC source is suddenly disconnected, when this one is disconnected, what is happening? The energy already stored in the capacitor is released to the resistor. So this is fully charged, and we take the source out. Then this is going to discharge. So that means the current is flowing this way. So charging and discharging actually here. So we can write an equation for this one. So we can say, since the capacitor is initially charged, we can assume that at time the initial voltage is V0. So at the beginning this was charged to V0 with a source, and then it is releasing, and after some time this is going to 0 volt. So starting from V naught and going to 0 volt, because when it is fully discharged, there is no voltage across the capacitor. Agree? Because it will be fully discharged. So you can apply KCL to this node here. So the current going through the capacitor is equals to when you consider these two currents, as you see, when you add both the currents, it should be 0. So you can write these equations actually, because for a capacitor we have this relationship, and we know I is equals to V over R. So we can get these equations. However, you don't need these equations for solving it. I will show you how to do it. Because you are getting equations, so this is the the start, or else these equations, from the equations we derive simplified the equations which we can use for solving questions. So those who came late, when we are doing a question, I will explain again the theory part. Okay. So as I told you, we are not going to use any of these equations. Instead of that, we are using this. So here, any time, so when it is discharging, the voltage across the capacitor is changing from V naught to 0. So V naught is the initial voltage, which is when it is charged, and we can find the voltage at any t time using this equation. Here E is the E in your calculator, and T is the time, and R is your resistor, and also this C is your capacitance, resistance value and the capacitance value. So here we can also write this equation with a tau. Tau means RC for RC circuits. So initial voltage is V naught and tau is the RC, and the resistor here, when you have many resistors, you need to find the Thevenin resistor, that will be your R here. And what is happening at the beginning, you have a V naught voltage, and it is going to 0 when the time goes to infinity, and this graph or this chart is our chart V naught E negative T over tau. And when the time is tau, this we call the time constant, and the voltage here will be 0.368 V naught. So when you substitute the value of tau here, that will be e to the power negative tau over tau. That means e to the power negative 1, isn't it? So negative 1 times V naught. So e to the power negative 1, if you put in the calculator, that is equals to 0.368. Okay, so that's the theory. When we do a numerical question, you will be fine. So I will explain again everything, so that's you will understand it better when we do a question. And also this part is I will explain again later on, when after you will understand after doing a numerical question. Okay, so to find these ones, we need to, V naught, we should find it, or it should have been given to us. And tau, you can find it. To find the V naught, actually, we consider the circuit when the time is less than 0, or when the time is just reach 0, and you can find RTH when the time is more than 0, and we can find we can substitute these ones, and we can find the equation for VT. We can find it using using two circuits. So we need to draw two circuits. One is when the time is less than 0, and the other less than or equals to 0, and the other one is when the time is more than 0. You have done this in your Thevenin as well, so I hope you should be fine with this. And let's take an example, and we'll do it. So only thing that you need to remember, you don't need to remember, actually we will give the equations for you, but for solving the questions you may need to write down these two equations for a step response for a capacitor. You will get the formula in the formula sheet for the exam. Yes, both the equations you will get them. Okay, so let's let's do this one together. Okay, so the thing is we need to find these two so that we can find the voltage across the capacitor at any time. So it's a function of time. So here first thing is for you to draw the two circuits when the time is less than 0 or less than or equals to 0. What they are saying, in the below circuit the switch was closed for a long time. So switch was closed. Am I right? So switch was closed. When the switch was closed, if I draw the circuit, my circuit would look like this. So even if you came late, you can understand now. Okay, I'm going to explain everything. So we have 1 ohm here, 9 ohms here, 3 ohms here, and 20 volts here, and we have a capacitor of 20 microfarads. Okay, so when the time is less than or equals to 0, our circuit will look like this because the switch was closed. Agree? This switch is closed, isn't it? Now, when it was closed for a long time, what is happening? If it is closed for a long time, capacitor will be fully charged, and capacitor in between the capacitor, this will be an open circuit because the capacitor only current is going to the capacitor when it is charging, and current is coming out from the capacitor when it is discharging. Now when you close the circuit for a long time, switch for a long time, the capacitor will be fully charged, isn't it? So what is happening? The current is coming out from this end and it is going to here and here, and the capacitor is charging. So when the capacitor is fully charged, what happened? This will be open. Agree? We discussed it last week. Am I right? Last class. So it is open. When it is open, your voltage across the capacitor will be the open circuit voltage here. Agree? So if this is open circuit, do you think the current coming out from the voltage source, when it comes to this node here at the top, is it splitting or is it whole, the current is going through the 9 ohms? What do you think? 9 ohms. Why is that? The other side is open, so the current can't go from that side. Agree? You will agree with that. So the whole current is going this way. So if you can find the voltage across the 9, if you find the voltage across these 2 points, that is equals to your V0. Agree? How can we find the voltage across 9? You can use the voltage division rule. So if you use the voltage division rule, V0 is equals to total voltage 20 times what? 20, we have two resistors in series because this one is not functioning because there is no current going in that way. So that resistor, you don't need that resistor at all, isn't it? Then what is happening? So we have 3 and 9 series, so you can use the voltage division rule. So when you use the voltage division rule, the total voltage is 20 and it is divided between 3 and 9. So what should be the rest of the part? 9 divided by 9 plus 3, which is 12. Am I right? So we can find the V0, which is equals to 20 times 20 times 9 divided by 12, which is equals to 15. Do you all understand how we got to 15 volts? Anyone have any question? Okay, so what did we find in this equation? We found the value for V0, which is equals to 15 volts, and how we found it, considering the circuit which is where the time is less than or equals to 0. Are we good? Any question? No questions? Okay, now the next one is for us to find this part. So in this equation, we are finding something for this equation. That's what we need to do because we need to find the voltage across the capacitor for any time t. So we already found V0 and we have to find the tau, then we are done. Agree? So to find the tau, that will be RC. So C is already known, which is 20 millifarads. Am I right? To find the R, what we have to do is, to finding this R, we need to draw the circuit when the time is more than 0. And we find the RTH across the capacitor. Okay, so now I'm going to delete this part, this circuit. And I'm going to redraw the circuit when the time is more than 0. So when the time is more than 0, can you tell me what is happening? The switch is, what's happening to the switch? Switch is open. Am I right? When the switch is open, switch was closed for a long time and it is opening, isn't it? You can see the arrow here. See, switch was closed. Now switch is open. So this whole part is disconnected from the circuit. Agree? And what is happening here? You have a circuit like this. Am I right? Agree? And we need to find the resistance, open circuit resistance across these 2 points. That will be your RTH. That's how we found the RTH. So now, can you tell me what is this resistance across these 2 points? 9 and 1 are in series. So RTH is 10 ohms. Am I right? So we can write the tau. Tau is equals to 10 times 20 divided by 1000, because why is that? It is in millifarads. We have to convert it to farads. So this 2 will cancel out. Then we have 1 over 5. Agree? So how do we write the tau? Tau is equals to RC. R is R we found 1 over 5. Yes, we already found the tau. Yes. So we are now substituting it in the equation. So let's substitute. So when we substitute it in the equation, Vt is equals to 15 e to the power negative 5t. Agree?
So the final answer is an equation?
It's an equation, yes. So it is, our final answer is this. So we can find, if you know the time in seconds, you can find the voltage across a capacitor for that time, after that time. So we just have to obtain the equation as a function of voltage across the capacitor as a function of time. Are we good? Any question? No questions? Okay, so that's good. Let's see whether we have another example that I can give you to try. Yes, I have another example. So I will give you time for you to do this one by yourself, and I will explain again the theory for those who came late. Okay, I'll give you time for you to do this one, okay? So do you understand what I said? So when the time is, so they are saying the switch was closed for a long time. So when it is just about to open the switch, when it is just about to open, or else when the switch is closed, you can redraw the circuit like this. Are you okay with this? Do you agree with me? Now, as the switch is closed for a long time, the capacitor will be fully charged, and the capacitor path is acting as an open circuit. Do you agree with that as well? So my circuit is look like this. Agree? Because the capacitor is fully charged. The capacitor should be here. But as it is fully charged, it is an open path. Can we find the voltage across these 2 points? That we call the V node. Agree? So how do we find it? If you find the voltage, so you can again use the voltage division rule, but you need to combine these 2 together. Are they in series or parallel? They are in parallel. So how do you add them together? 12 times 4 divided by 16. Is that right? And it is 3 ohms, isn't it? So your voltage 24 is divided between 3 and 6, because 3 and 6 now are in series with each other. Agree? So how do we use the voltage division rule and find the V node? The total voltage is 24 times 3 divided by 9. So that will be 3 times 3, 3 times 1, 3 times 8. So your V naught is 8 volts. Agree? So we found the V naught, which is 8 volt, and we used the circuit which is T less than less than or equals to 0 just before opening the switch. So up to here, are you guys okay up to here? Any question, anyone?
I'm just a bit confused. Why did we use 3 again?
Because voltage, because this one, when you add these two together, that is 3. Am I right? So you have two resistors like this, 6 and 3, and your voltage is 24 here. So how do you divide the 24 between 6 and what is the voltage division rule says? Voltage division rule is equals to voltage times the R1. If you want to find the V1, that will be R1 divided by R2 plus R1 plus R2, isn't it? So you, to find the voltage across 3, you divide 3 by 3 plus 6. 3 and 6 are in series with each other. Are we good? Okay. So are we all okay with 8 volts? Okay, can I give you a few minutes for you to do the tau now? Okay, so now let's find the tau. To find the tau, we need to know the resistance, and capacitance is already known. Am I right? Capacitance is 1 over. Okay, so we are going to find the tau. Tau is RC. So R is what? R is 1. We need to find R is the RTH across the capacitor when considering the circuit which is time is more than 0. And this capacitance is already known. It is 1 over 6 farad. So let's redraw the circuit. When the time is more than 0, the switch was open, and this part of the circuit is not there because the switch is open, it is disconnected, and your circuit will look like this. Do you agree with that or not? And RTH means what? The open circuit resistance. So you make this open and find the RTH. So this 12 and 4 are in parallel with each other. Am I right? So we already found it. So RTH is 3 ohms. Agree? So your tau is what? Tau is equals to RC, which is 3 times 1 over 6, which is equals to 1 over 2. Am I right? So you can now write the equation Vt is equals to V naught, which we found as 8, e to the power negative 2t. Agree or not? Equation was what? V naught is equals to, Vt is equals to V naught times e to the power negative t over tau. So when you substitute the tau and the V naught which we have found, you get this. So it's an equation with time t. So whatever the time, we can substitute the time and we can find the voltage across the capacitor. Am I right? Any question? Okay, now.
What do you call that? The word? What's that?
Which one?
The one that closes the
Switch?
It's the switch.
Yes, it is the switch, like you know that you have switches everywhere. That is switch. Switch open and switch close.
When the switch is closed, we can find out.
No, in sometimes, like you know, we can't exactly say whether the switch is open or closed. In sometimes, in the questions, we'll do some questions like that. Sometimes the switch is open for a long time and close. So RTH is always when the time is more than 0. So if the switch was open for a long time and closed, then your RTH need to be found when the switch was closed. In this one, switch was closed for a long time and then it is open. Sometimes in some questions they are saying switch was open for a long time and it is closing when the time is equal to 0. It depends on the question. We'll do some questions. If you remember this, to find the V naught you consider the circuit which is time is less than 0 to find the V naught. To find the tau, you always use the circuit which is time more than 0. Remember those two, that then you will be able to draw the circuit. Okay, can I move to the next part? RL circuits. I don't have a circuit here, but RL circuit is where you have a inductor, not a capacitor. Okay, so you have resistors with an inductor. Again, for this one, it's very similar to RC circuit. So it has an initial current, and it has the current is going to 0 when the time goes to infinity. So we can do it like this. Equation for current in the capacitors, we wrote an equation for the voltage across the capacitor, but for an inductor we write an equation for the current across the inductor, which is equals to this. So instead of having V naught, you are now having I naught, and we are finding an equation for the current. And the tau is different here. Before, the tau was RC, but here the tau is L over R. L is the inductance and the R is the RTH. To find the I naught, as we have done before as well, you consider the circuit which is time less than 0, and to find the RTH, you can find the resistor or the open circuit resistance, Thevenin resistance across the inductor. Always it is open circuit. Okay, so shall we do a question? Yeah. You need these two equations for that, okay? But equations you don't need to remember. We will give you the equations. Okay, let's do this one. So switch was closed for a long time and it is opening. Okay, I'll give you some time for you to think and do it, because you know what is happening to an inductor when it is fully charged. What is happening to an inductor when it is fully charged? Capacitor is open circuit, inductor is short circuit, isn't it? Yeah, so I want you to first draw the, so we need to find these ones. We need to find I naught. To find I naught, you need to draw the circuit when the time is less than 0. And we need to find the tau. To find the tau, you need to find the RTH, considering the time when it is more than 0. So they are saying switch was closed for a long time and it is opening. So when the time is less than 0, your switch was closed. Am I right? And when it was closed for a long time, your inductor will be fully charged. Agree? Inductor will be fully charged and this path will be a short-circuited path. Agree or not? So if you find the current across this one, that will be your I naught. Do you agree with that? Okay, can you find the current I naught? You can use mesh, node, whatever the things that you have done so far, it's okay. So, okay, let's apply the mesh here to see, like, you know, the first mesh is 5 amps, the mesh current is 5 amps. Other two, I put I1 and I2. So I'm going to write in the mesh, what we do, we apply the KVL. So if I apply the KVL to mesh 1, I can write 12 plus 8 is 20. So 25 I1 minus 12 times 5 minus 5 times I2 is equals to 0. Am I right? And if I apply the KVL to mesh 2, I can write 5 times I2 minus I1 is equals to 0. So we can say I1 is equals to I2. Is that right? Am I right? So we have done this in week 2, isn't it? Week 2 or 3. Mesh. So I can substitute if we find the I2, then we can find the I0. So I'm going to substitute this here and here. So we have 25 times I2 minus 12 times 6 is 60 minus 5 times I2 is equals to 0. So I can say I2 is equals to 60 divided by 20, which is equals to 3 amps. So if you see here, so this way 5 amps going and this way to 3 amps going. So the current down, the net current down, which is your I0, is equals to 2 amps. Do you agree with me? So I have applied the mesh to this one. So we have 25I1 minus 12 times 5, because 12 times 5 amps, minus 5 times I2 is equals to 0. So are you okay with this mesh current equation for the mesh 1, which is this one? You don't have to use the mesh, okay? You can use any method. We just have to find the current across the inductor, I node. And you can write the mesh to the second one here. So you only have one resistor, that is 5 times I2 minus I1 is 0. So we can say I1 is equals to I2. Agree? So I'm substituting that one in this equation. So we can find I2. So I2 is 3 amps. So 3 amps, if you look at this one here now, 5 going down and 3 going up, the net current going down is 2 amps. So your I0 is 2 amps. Do you agree with that? Any question? What? Which one? Yes, I0 is the current. I0 is the current across the inductor. So I'm just drawing this. So this side we have a 5 amp going. And this side we found that 3 amp is going. So the net current going down is 5 minus 3, which is equal to 2 amps. Am I right? Any question? No questions? So we have already found the I0. I0 is equals to 2 amps. Now I want you to find the tau, and I want you to draw the circuit when the time is more than 0, and I'll give you some time, but if you have any questions regarding this while others are working on the tau, you can ask, okay? Okay, I'm deleting this part because now we are okay with I0. We need to find tau. We have half of the theory to do. Are we good? Any question? Because I applied the KVL to mesh 2. When I apply the KVL to mesh 2, write the KVL equation for mesh 2. What do you have? Yes, is equals to 0. So I1 is equals to I2, isn't it? Now if you draw the circuit when the time is more than 0, I already drew it on the board as well, so you got this. And RTH is the open circuit voltage. So that means the open circuit voltage across the inductor is opening. You are opening these 2 points. Then you have this 5 and 12 and 8 like this. You need to find the resistor RTH here. And you can find it while others are working on the I0. What is RTH? 12 and 8 time what? Series, because they are in the same path. So 12 and 8 are in series, which is 20, and the 20 and 5 are in parallel, isn't it? So 20 is like this, and the 5 is like this. So they are parallel to each other. So your RTH will be 5 times 20 divided by 25, which is 4 ohms. Agree or not? Okay, so what do your tau? Tau is equals to L is 2, R is 4, so that will be half. Now you can substitute everything here. When you substitute, I naught is 2, e to the power negative t over 2, that means negative 2t. So this is our equation. This is our current. Current is 2 times e to the power negative 2t. Are we good? Any question? If you have any question, ask. Okay, I'll give you some time, and then we are moving to the second part of the theory. Okay. This we call the step response of RC circuits. The difference between the step response and the natural response is the presence or absence of an independent source in the circuit. So if you draw here the circuit when the time is less than 0, if you draw the circuit when the time is less than 0, can you tell me what is the circuit? The switch was open for a long time, isn't it? So when the switch was open, so your time is less than 0, switch was open, so this part of the circuit is not there. Agree? So your circuit will look like this. Before closing the switch, your circuit will look like this. Am I right? And when the time is more than 0, the switch was closed. So you have both the parts of the circuit. So your circuit will look like this. Am I right? So when the time is, if you look at here, when the time is more than 0 or less than 0, in both the cases, your capacitor or else your circuit has sources. Am I right? In the previous one, when the time is more than 0, you didn't have a source. That was source free. But here you can see there are sources in both the circuits. So your capacitor is not fully discharged. So it's not going to 0. It has some voltage across this one. So here the equation that we are going to use is the one that you see here. So you can see we have an additional term which is V infinite, because our capacitor is not going to 0. In the previous one, V infinite was always 0 because capacitor was fully discharged. Now to find the V infinite, the only thing you are doing everything in the same way that you did. So you can find the V naught from this one, find the V naught from using this one, and you can find the RTH using this equation, and V infinite also using this equation. Okay, so when the time is more than 0, you can draw the circuit and you can use that to find the V infinite and also RTH. But to find the V naught, you using the circuit which is t is less than 0. So can I give you few minutes for you to work on this one? So you can see voltage is not going to 0 when the time goes to infinite. Voltage is reaching another value. So that will be your final voltage. Do you understand this or not? Okay, so shall we do this question? So do you understand how I drew the two circuits? Time is less than 0, switch was open. When the switch was open, the right hand side of the circuit is not connected. So you only have the left hand side of the circuit. Agree? When the switch was open, you only have the left hand side. When the switch was closed, so you can see the arrow for the switch. When the switch was closed, you can see both the parts of the left hand and the right hand side of the circuit is connected. So you can draw we need to draw the two circuits, when the time is less than 0 circuit and when the time is more than 0 circuit. Are we good? Any question? Can you find the V naught, please? Yeah.
So like if the t is less than 0, it becomes the open circuit.
Because you see the circuit, here. See here, when the time is 0, only switch is closing. Before that, switch was open. Arrow is going down when the t is equals to 0. Before that, arrow is like, the switch was open, not connected. Agree or not? Look here. See, when the time is 0, only you are putting this one back to here. So this will be connected only when the time is 0. Before that, it was open. Open means there no current can go in the right hand side.
Well, in previous question,
It depends. Yes, it depends. Sometimes the switch was open and closing. Sometimes the switch was closed and opening. You have to read the question. You have to see the arrow. Always we can't say switch was open or closed. Switch can be open or else it can be closed.
So we identify that depends on
the arrow. Yes. And also in the question we write, you can read it as well. They say here you don't have a question, but if you have a question, proper question, they say the switch was open for a long time and it is closing when the time is equals to 0. So can you please find me the V note? What should be the V note? V note is what? So when the switch was open for a long time, your capacitor will be fully charged. Do you agree? And this will be open. And if this is open, there is no current going across the two. So the voltage across the capacitor is same as the voltage of the source. Do you agree or not? Okay, so we notice 10. Is that right? Two resistors there, but when the capacitor is fully charged, that path is open circuit. So there is no voltage drop across the two. Am I right? No current means no voltage across the resistor. Now can you find the voltage across the capacitor when the time is more than 0? You use that circuit here. So this is across these 2 points. So we have 2 ohms and we have 6 ohms. So again when when this one you need to find when I will write. So this need to be found when the time goes to infinite, isn't it? Voltage across the capacitor when the time goes to infinite. That means the capacitor again will be fully charged, isn't it? When time goes to infinite, again there is this path will be open circuit. Do you agree with that? Okay, so that is open. So you have just one mesh and you can find the current. You can apply KVL to that one, isn't it? So if you apply KVL to that, what you can write? 50 volts. So if you apply KVL to this one, you can start at a point and you go around. So when you go to the negative side of the 10, it is negative 10 plus 6i and 2i. You can add them together. They are in series. So 8i minus 50 is equals to 0. So you can say 8i is equals to 60. So your I current across this going along this path will be 60 divided by 8 amps. Am I right? So what's that? 7.5 amps. Now you can find the voltage across the capacitor here, voltage V infinite. So that V infinite you can write considering the left hand side or right hand side. If you consider the left hand side, what do you have? You have this 10, and you have here plus and minus V infinite. So you have 2 ohms here. A current going this way is 7.5. So if you apply KVL to here, so you have negative 10 plus 2 times 7.5 plus V infinity is equals to 0. So you can say V infinity is negative 5 volts. If you do it for the other side also, you get negative 5. So you know V infinite and you know V naught. Only thing is finding RTH. Yeah. What's that? V infinity is the voltage across the capacitor when the time goes to infinite. Okay, when the time goes to infinite, your capacitor will be fully charged, isn't it? And that path is open circuit. So if you consider that the 2 points, if you find the voltage across these 2 points across the capacitor, that will give you the voltage across the capacitor when the time goes to infinite. Are we good? So we found V naught is 10 and V infinite as negative 5. RTH you can find. I have to delete some of these parts. Are you guys okay? So RTH is the Thevenin resistance across the capacitor considering the second circuit, this one. So Thevenin, what do? You switch off all the sources and you find the resistance across that open path. So if you consider this 2 and 6, they are parallel to each other when you consider across these 2 open circuit points. So 2 and 6 are parallel. So you can find the resistance, which is 2 times 6 divided by 8. Am I right? So that is 6 over 4 ohms. So you can find the tau, and you can tau is all for RC circuit, it is RC. Am I right? So you have the C, which is 1/3, and R is 6 over 4. So that will be half. So tau is half. So you can substitute the numbers to this equation and you can find, you can write this. So what did we get? We get negative 5 here, and this one was 10, and negative will become plus 5, and e to the power negative 2t. So this will be your equation. You can simplify it and write it. Vt is equals to negative 5 plus 15e. That makes sense. I will give you one question for you to do. Can I give you one question for you to do? What's that? Yes. Yeah. So this is the summary, okay? So you get this equation, and also you get another one for tau. Tau is equals to RC for RC circuits. So to find, you can find V naught by using the circuit when the time is less than 0. Then you use the circuit which is time is more than 0, and you make the time to infinite and you find the V infinite. And you can find the R using this time is more than 0 circuit and finding the open circuit resistance across the capacitor, and you substitute all that to this equation and you will find it. So that's what you get the equation, so you don't have to worry about it. Okay. Okay, I want you to try this. That is the same one that we did. Okay, we already did that. Okay, that's good. You need to draw the circuit when the time is less than 0 and more than 0. So it's, even though it is the same question, you can try this one by yourself. So first, without looking at my working outs, can you draw the two circuits when the time is less than 0 and when the time is more than 0? Can you draw the two circuits? Okay, I will change this this circuit. So because we have already done this one. Okay, so what I'm going to do is I will change the arrow. Okay, so that's the only difference that I'm going to make, because otherwise it is the same question. No, you know the answer. So this way round. Okay, when the time is less than 0, your switch was closed. Opposite, yes. And when the time is more than 0, switch was open. Okay, I'll give you time for you to do this. Okay, so draw the two circuits and yeah. So what should be the circuit when the time is more than, less than 0? Switch is closed, so your circuit should look like this. Agree? Do you agree with this? And when the time is more than 0, switch was open and you have this. Okay, so are you okay with drawing the two circuits? So you use the first circuit to find your V naught. So V naught is what? V naught is the voltage here, this point V naught, and capacitor is fully charged. You are keeping the switch closed for a long time, so your capacitor is fully charged. So how do we find the voltage across the capacitor? So this path is open because the capacitor is fully charged. So you need to find the voltage across these 2 points, that is your V naught. So that voltage, if you consider this path here, you can write KVL to that and you can find the voltage. So you can write the voltage V naught. You start at a point and you go around this one. I already told you that. So you are going to the -10 and plus 2 times I. So if let's find the I going across the I is going like this, because middle path is not there anymore. So 2I plus V naught is equals to 0. So you can find V naught, which is equals to 10 minus 2 times I. So you can find I if you apply KVL to this big mesh. If you apply KVL to big mesh, you get -10 plus 8 times I minus 60 is equals to 0. So your I is 7.5 in the same way. So you can substitute the I value here, and V naught is equals to 10 minus 15, which is -5. So now you can see we have V naught as -5 volts. It's the same thing, but like now your situation is opposite. Current is 7.5 like in the previous one. So even as I told you, you can apply KVL to this one here as well, and you get the V naught. So if you do that, you have -V naught plus 6 times I minus 50 is equals to 0. So your V naught, you can write it as negative, again, negative V1, 50 minus 6 times 7.5, so you get V naught as -5 again. So even if you consider the right hand side or left hand side, you still get the V naught as -5. Are we good? So can you find me the V infinite? When the time goes to infinite, again your capacitor will be fully charged, isn't it? So this part will be open and this will be your V infinite. So there is no current going across the two because it is open path, and voltage across the capacitor is same as the voltage of the source. So your V infinity is 10 volts. Am I right? So this will be 10. This is also 10.
If we use the different sides and 50 volts.
No, no, no. How come?
It's open.
Now what is happening to your R Thevenin? It's just 2 ohms. Am I right? Do you agree with that? Because you switch off the dependent source 10 and you only have 2 ohms. So your RTH is 2 in this case. In the previous one it was different, but now we are using, like, you know, the situation is different now. So you can find the tau. Tau is RC 2 times 1 over 3, which is 2 over 3. So your tau is 2 over 3. Now you can write the equation. So that will be V infinite is 10 minus, oh sorry, plus minus 5 minus 5 minus 10 e to the power negative 3 2 over 2. So that will be 10 minus 15 e to the power negative 3 t over 2. This is what I got. Do you get the same? Okay, so this is the equation for the step response of RL circuit. So that is with inductors. Here again, we have to draw the two circuits when the t is less than 0 and t is more than 0, and we need to find the current across the inductor I naught, and also when the time goes to infinity, what is the current across the inductor. So let's do this question and we'll see how we go. So equation is very similar. Instead of voltage, we only have current, and the tau is different here. If you can remember, tau is not RL, it is what? ROL. That's the only difference. And also instead of voltage, we have current here. So let's do this question, okay? I should have the question in the other slide as well. You need to find the I naught using the circuit t is less than 0. And you need to find the I infinite considering the circuit t is more than 0, and also RTH considering the circuit t is more than 0. So I want you to draw the two circuits. Okay? Okay, please draw the two circuits, please. So look at the arrow and draw the two circuits. So I want you to draw the circuit when the time is less than 0 and also when the time is more than 0. So when the time is less than 0, switch is what? Switch is open. Am I right? When the time is more than 0, switch is closed. So how should be the circuits? And this one, you can use this to find the I naught. And the next circuit will be do you understand why I got these two circuits? Any question? Are we good with this? Are these the two circuits? When it is open, we don't consider the 12. Yes. Yes, because that path is open, that resistor doesn't, like, no current is flowing across the resistor. But you can ignore it to find the voltage, but if you want to find the RTH, you have to, like, in this case, we are finding the RTH not using that circuit, using this one, because that is the circuit for t is more than 0. But you can't ignore any of the resistors when you find the RTH. Even though there is no current flowing across the resistor, still you need to consider it to find the RTH. Do you have the same two circuits or different? Now, the switch was open for a long time. So what is happening to the inductor here? It is a short circuit path, isn't it? If the switch was open for a long time, that means your inductor is fully charged and you can find the I naught. So how do we find the I naught? Current division rule, 2 amps coming to this node, splitting between 4 and 4. So your I naught is 1 amp. That's simple. Am I right? Equally dividing because it's only two, both the same, isn't it? So you don't have an inductor anymore. It's short circuit path because you have the inductor, but it is fully charged. Am I right? Did you get this or not? It's a very simple one. You have 2 amps coming to that node, then splitting between 4 and 4, which is half. 1 amp. If you finish this, you can do the time goes to infinite. What is happening? Again, this will be fully charged. Now your 2 amps is coming to this node and splitted between 3 resistors. You can use the current division rule if you combine these two and make it to a single resistor. Do you agree? Yes. So when you combine these two, they all three are in parallel to each other. But don't touch the 4 because we need to find the current across the 4. So when you add 4 and 12 in parallel, what will be the resultant? 3. So what is the current going across? So this will be your current I infinite. So I infinite you can use using the current division rule. Tell me how to write it. Total current coming to that node is 2 amps and you times by which resistor? Opposite one, isn't it? Am I right? So to find the current across the 4, you times by 3 divided by 3 plus 4. Am I right? You already learned about the current division rule. So that will be 2 times 3 divided by 7. times 3 divided by 7.886. Okay, so I infinity is 0.86, so this is 0.86, and this one is 1 amp. Any question up to here? Are we good? Give me a few minutes, so I will find the R as well, and then I'll go back. Okay, so how to find the R here? So you use this, so I'm deleting the unnecessary part. So you use the time is more than 0 circuit here, and you find the RTH across the inductor. So you make that path. So you switch off all the independent sources, and when you switch off a current source, that path will become no current, open circuit. So you have 4 and you have 12 and you have this, and you have to find the RTH here, because there you have your inductor. So this will be 4 ohms and 12 ohms and 4 ohms. So what can you say about this 4 and 12? These two, are they in series or parallel? Parallel. So that will be 3. Am I right? So 3 and 4 are in now what? Series. So 3 and 4 are in series. So your RTH is equals to 7 ohms. So you can find the tau. Tau is equals to R over L, which is equals to 7 over 3.5, which is 2. So you can put your tau as 2. So if you write the equation now, 0.86 plus 1 minus 0.86 times e to the power negative t over 2. Okay, so we need to wind up the class because there is another class. But we are going to do more questions on Thursday. And I hope you understood this. Summary in one slide. If you if you understood this one, that should be more than enough. So you have the equations. You just need to know the steps. That's it. Do you guys have any question? Yes. Okay.